Okay, in this problem, what we've got to do is to find some expression involving x and a and theta. So, and they tell you that the triangles in there are the angles. If they look like right angles, they are right angles. So that's what I've done here. I've just gone in and labeled all of the things that the angles that look like right angles. I've labeled them as right angles pretty much in there. There's a few in there, but that's good. So all right, so then if I look at the relationship here that I've got going on, so for instance, here I've got in this triangle right here, I've got a 90-degree angle and I've got theta in there, and so this angle up here, right, would have to be 90 minus theta, and I'm just going to call that alpha. So I'm going to label that everywhere it appears right here. So it would have to be in here and in here and in here and all these different spots right here. So looking at these triangles, I have a bunch of similar triangles in here. But I've also got, if you look right here, this big rectangle right here. Right, this would have to be a right angle here because of the relationship between theta and alpha. That's right angle because it looks like one. This is a right angle, and this one right here is also a right angle. So I've got a rectangle in there, and so these opposite sides of the rectangle are equal to one another. So then what that tells me is that I've got not just similar triangles anymore, but I've got a congruent triangle by the angle side angle property, right? Two angles and an included angle right here. Here's the angle alpha, then this side and theta, and right over here in this triangle I have alpha, this side and theta. And so those two triangles are now congruent, and so I'm just going to go through and label the parts that are congruent here. And I'm just going to call those side lengths D, E, and F in there. And so what I can do is now go through and look at some of the relationships here between theta and A. So looking at it, I've got theta, and the adjacent side is A, and then the hypotenuse over here, I want to use that double tick mark side over here because it's related to this triangle over here. So I'm getting closer to that triangle there. So I have that relationship. Cosine of theta is A over E. Then looking at this triangle, I have theta here, and then this is the opposite side and this is the adjacent side. So that's going to give me the relationship that tan of theta is F over E. And then finally getting back to X over here in this triangle, if I look, I've got theta here, and X is the adjacent side, and F, which I have here, is the hypotenuse of that triangle. So I get this relationship. Cosine theta equals X over F. So two of those things are equal, so I can set them equal to each other. And then if you look at that, I can rearrange it slightly, right, and get F over E equals X over A, so that is exactly what I have here. So I'm just going to replace that. Tan theta equals X over A, and then just rearranging that gives the relationship that they have there as the answer.